So today we're continuing on with section 3.5, conditional statements. Let's start by just looking at this statement. If Carl is texting, then he is using a cell phone. How is this a conditional statement? No. If and then. Good. So the if and then makes this a conditional statement. Now the next statement here, if he's using a cell phone, then he is texting. Is that conditional? Yes. There's also a special relationship between the two of them. No. They're kind of opposite, which we call the converse. So these two statements are converse, which means they are switched around. Now let's look if they're true or false. So the first one, if Carl's texting, then he's using a cell phone. True. Okay. If Carl is using a cell phone, then he is texting. False. Now if you claim that something is false, you need to provide a counter example. What is the counter example in this case? Good, he could be calling. The next thing you need to be able to create is a truth table. There is a link to a truth table video on your handout if you need extra help with this. But let's say that we have P, Q, and the conditional statement P such that Q. So in this case, P is your hypothesis, and Q is your conclusion. So let's say we're talking here about practicing indoors versus outdoors. So the conditional statement is, if it's raining outside, then we practice indoors. What would make that hypothesis true? If it's raining outside. So if it is actually raining outside, your hypothesis is true. Then what would have to happen for your conclusion to be true? Good, you have to play indoors. And would that make your whole statement true? Okay, good. How about if it's not raining outside? What are your options for your conclusion? You can practice outside, which would make your conclusion false. And that actually keeps your conditional statement true because since you did not actually have to prove your hypothesis, your statement was not proved wrong. So that means it's still true. How about if your hypothesis is false, so it's not raining, but you practice indoors anyways? It's actually still true because your hypothesis, again, was not tested. It's not raining outside. Now, what if your hypothesis is true, so it's raining outside, but you decide to practice outdoor anyways? Good. That actually makes your whole conditional statement false because you did not go through with your statement as it was said. So that is a truth table. So then we have biconditional statements. What does it mean if something's biconditional? Pardon? Good. Both the statement and the converse are true. So for example, the statement here would be if you live in Nunavut, you'll experience days with less than 9.5 hours of daylight. That is true. The converse, if you have less than 5.9 hours of daylight, you live in Nunavut, is not true because you could, counterexample, live in Alaska or in jail. So biconditional means that they both have to be true. This statement, therefore, is not biconditional. Biconditional, both converse and original statement need to be true. And how do we write things in that case? If and only if. Good. So if your statement is biconditional, then, notice that that's a conditional statement. If it's biconditional, then you need to write it as if and only if. So that needs to be put in that sentence. All right, so example 6 says a quadrilateral is a square if and only if all of its sides are equal. Is the statement biconditional? So in order to do this, let's start by writing out the original statement, then the converse statement, and then let's see if they're true to prove that it's biconditional. So if the original statement is true, but here we see that the converse is false because we provided a counterexample of a rhombus, that makes this statement not biconditional.